Alright, we're going to prove that these two quadrilaterals are congruent. And the first time I set out to do this, the proof got so unwieldy and terrible. I just kind of lost track of what was going on. It was awful. So I decided I'm going to take one little liberty with this. I think that'll make the proof a lot shorter. Okay? I'll explain it to when we get there. Alright, so again, the trick with a lot of these proofs is we're going to find triangles in here and prove that the triangles are congruent. And somehow using the information that the triangles are congruent, we're going to piece together that the rest of the information that we need is all there. Okay. So, a couple things here. We have that this side is congruent to this side is congruent to this side, and that these triangles are congruent to these triangles. So to prove that the quadrilaterals are congruent, all we need to show is that AD is congruent to PS, and CD is congruent to RS, and that angle ABC, or I guess I could just say angle D, is congruent to angle S. Which, by the way, and I'm going to start out, we have so far that, just to be thorough here, that AB congruent to PQ, we have BC congruent to QR, we have angle A congruent to angle P, angle B congruent to angle Q, and angle C congruent to angle R, and all that is given, right? So I'm going to connect these P and R with a line across here, a little segment, to make a triangle up top. And we should see the triangle ABC is congruent to PQR by side, angle, and side. Right? So you got two, right? One pair of congruent sides, another pair of congruent sides, and the angle in between them is also congruent. So we can say that triangle ABC is congruent to triangle PQR by side angle side, which then tells us that segment AC is congruent to segment PR. And that is corresponding parts of congruent triangles are congruent. Okay, so now we need, if we can just show that angle CAD is congruent to angle RPS, and that that angle ACD is congruent to PRS, then we would have that this bottom triangle is also, these two bottom triangles are also congruent, because we would have angle side angle, right? So we're going to do that, because here's what we're going to do. We're going to say that angle BAC, right? Angle BAC congruent to QPR, and that angle BCA congruent to QRP. And that is also corresponding parts of congruent triangles are congruent. And then we're going to say, and here's where we're going to make our little bit of a leap here. We're going to say that because of that angle CAD, okay, angle CAD is congruent to RPS, and that angle ACD is congruent to angle PRS. Now here's the thing. The reason we're going to say we're going to call this angle addition. Basically, we know that angle A is congruent to angle P, And we know that the top part of angle A is congruent to the top part of angle P. And so if I take, if I remove this portion here, or this portion here, this thing, I'm removing the same amount. So I'm taking equal amounts from equal amounts, and therefore what I'm left with is also equal. And there's a lot of steps we have to go through to actually make that claim. And I tried to write it all out. I'm like, this is getting so confusing, right? But basically, you're saying, as I'm swinging open this whole angle, opening up the angle all the way, both angles all the way, they're the same. And if I open it up, just so far, going this direction, right? And I've opened it up the same amount. And when I open it up all the way, it's the same. So that little extra bit must also be the same. And kind of the shortcut term for this is angle addition. So anytime you've got, we got, two equal angles, I take equal portions away from them, you kind of use this angle addition claim here. It's a shortcut a little bit. And now because we know that, and we know that AC is congruent to PR, we now know that the lower triangles are congruent by angle side angle. So we'll go back and we'll say that. We'll say that triangle, and that is going to be ACD. ACD is congruent to triangle. So that was ACD, PRS. PRS by angle side angle. And because of that, we now know that AD is congruent to PS, and DC is congruent to SR, and angle D is congruent to angle S. So we'll say AD congruent to PS. We've got DC congruent to SR. And we've got angle D congruent to angle S. And this is all corresponding parts of congruent triangles are congruent. And that gives us the final pieces we need to say that A, B, C, D is congruent to P, Q, R, S. Okay. A definition of congruence, you could say. So we've met all the criteria. All the sides are match up, all the angles match up. One little thing, we could have said, by the way, that angle D and angle S are congruent right from the beginning. Because in the similar way we've talked about, I don't know if I talked about it before, sorry. But if I've got two polygons that have equal numbers of sides or equal numbers of angles, it's the same thing, and I know all the angles pair up and are exactly the same, all the angles pair up and are congruent except for one last angle, well, any polygon, any quadrilateral, the angles always add up to 360, triangles always add up to 180, pentagons always add up to 540. There's a specific number of degrees for every single polygon. So if you know what all the angles are but one, you just do a quick calculation. You know the last one. If you know that all the angles match except for one last pair, then whatever that last pair is, they must also match. So it could have just jumped straight to that.